Welcome to this Sci Cafe colloquia talks that are organized by the International Relations Office of Hellenic Mediterranean University, the Athena University, and the Hellenic Mediterranean University. It's a great pleasure to have with us Professor Denia Kolokocha. A few words about Denia, apart that she's a marathon runner, a very good one. Actually, I'm trying to train in the stadium in Chania, and I'm jealous of her because I cannot believe that how about her endurance and how fast and how long she runs, but this is beyond this talk. So Denia has a bachelor's degree in physics in 1991 from the University of Athens, 1994 a master's degree in environmental physics from the University of Athens. Then she moved to one of the most prestigious UK universities, UCL, in order to obtain her master's degree in architecture, environmental design and engineering. And then she received her PhD in 2001 from the Electronic and Computer Engineering Department in Technical University of Crete. She is now a professor in the Technical University of Crete. She was an ex-TI of Crete university, nowadays known as Hellenic Mediterranean University. She's very dynamic, and this is very important. Her research interest includes air quality energy, zero emission buildings, green buildings, energy management system, monitoring environmental parameters in building in urban areas. She's one of the most cited scientists in energy management. Her research work has received more than 6,000 citations, and she has included among the top cited scientists in a recent report release. Always is very positive to us, so I would like to thank again Denia. Whenever we are asking Denia to contribute with her knowledge, is with us. So this is something that we appreciate a lot. The floor is yours, Denia, for the next, let's say, 40 minutes in order to give some time for the people to ask questions. Thank you very much.
Thank you for the invitation, Kostas. It's very glad to be here today with all these people that we worked together in the past, and we spent a lot of time in TI of Crete, also in other projects. So my talk today, I don't know if you can see my screen. I will, is it okay? Okay, my talk today is about the perspectives of energy in the built environment. The talk is from buildings to smart cities, although I will focus in cities and the work that has been done in the last 3 to 4 years in the lab that I am the head in the Technical University of Crete and the various projects that we are. I will start with the challenges that we face now in the built environment. First of all is the fact that in less than a human lifespan, less than 70 years, the face of Earth has been transformed. In 1950, only 29% of people lived in cities. In 2010 was 50% and is increasing. You see here, for example, in the US, the blue areas are the cities that existed in 1950, and the red areas are cities that are expanding, and how the existing cities are expanded the last 70 years. All these challenges for the cities create a lot of pressure in the environment. In 2006, the world's population consumed 2/3 of the total energy used and emitted more than 70% of the energy-related carbon dioxide emissions. And we expect this to rise in the upcoming period. So the challenges for the cities are very, very important. And we saw that also in the COVID pandemic, how cities are affected. So how can we work for sustainably resilient cities? We should cities and communities should protect and ensure the quality of life, offer income and employment, economic growth, be inclusive and respectful of individuals, of their natural and cultural heritage, become also participatory and collaborative, so people participate in the decision-making mechanisms for solutions, policies, services, also regenerative to provide affordable, sustainable and modern energy, support the resilience to disruption and risks, and embrace cradle-to-cradle life cycle system thinking and circular economy. So my presentation will have 4 axes. The first one is the data and how data affect the buildings and cities and communities, and the work that has been done in the collection of data in the built environment. So also in the role of smart grids in the built environment and cities, the climate change, and how nature-based solutions can provide a solution to the challenges that we face. Starting with cities and data. Data are exploding. Security footage from video cameras, transponders, collecting highway tolls, and all the sensors that are now inserted in our city life provide new data about cities operations and new also problems and challenges. So big data analytics will turn this vast amount of data into valuable and usable information and knowledge if we learn how to exploit them. And this will support the creation of new business, and this business develop applications using city data will provide innovative citizen services and create new jobs. So to be more specific, I will start discussing with you the work that has been done in a project called the Horizon 2020 project called Zero Plus. The aim of the project is to achieve nearly zero settlements, buildings that are in a small neighborhood using advanced energy technology. So the objectives were 3. The first one is to reduce the operational energy of residential communities to an average of 0 to 20 kilowatt hours per square meter per year, compared with the current average of buildings that is 70 to 230 kilowatt hours per square meter. At least 50 kilowatt hours per square meter per year renewable energy generation in these small communities and buildings. And this to be done by an investment cost reduction of at least 16% compared to a current cost of the new net zero energy buildings and communities. For the role of data on that, we designed for this project a WebGIS platform, open WebGIS platform, not relied to a specific vendor, but we used open tools. Then we have four case studies around Europe that were constructed in the framework of the project. One is in Italy, one in UK, in France, and in Cyprus. In Greece, we couldn't have then a case study because the construction industry was affected by the crisis. Then we have various measuring devices from various technologies that we integrate them in this database. We have intelligent modems, a key performance indicators calculation, and these also are presented with a front end to the end users. I will talk about that in a few slides. What are the innovative technologies that we can include in these buildings and settlement level? First of all, we have here you see the advanced building envelope components, for which for our case were a photocatalytic insulation. So it was an insulation that was put at the outdoor of the facade that had photocatalytic components, and also some photovoltaics that called SB Skin that produced energy from the facade. Then we have the energy production technologies, various aspects. For example, this called the wind rail that on the top has a production of energy through photovoltaics, but exploits also the wind flow through a turbine that is included here. And this is installed in a roof. This is called the wind rail. Also, Lear Fresnel solar collectors and other technologies. Then we have thermal energy storage using various systems. And for the building sector, we have advanced heating, ventilation, and air conditioning systems, and also in smart controls and monitoring of the indoor environment. And all these are integrated in an integrated resources management system where we have the converters, the distribution network, the microgrid here, light control of the outdoor lighting, a low voltage distribution network using Wi-Fi to connect the outdoor environment with the buildings. To be more specific, you see here this SB Skin, which is, you see here 3 pictures of the SB Skin, is multifunctional building panels for energy saving and production roofs and facades. It is patented as a high insulating glass block, so it has also insulation in the back and small photovoltaic panels on the front. It gets out in different colors and is modular, so it can be assembled in different ways. This is also the XPS insulation, which combines a reflective photocatalytic thermal insulating panel, and during the summer, the surface temperature of this material can be at least 3 degrees reduced compared to a conventional construction of buildings. And this cost is 20 euros per square meter. I talked about that. This is a wind rail provided by a specific company called Anergy. As I said, you see here that the air is moving on the system. There is a turbine, and the turbine is moved and produces some amount of energy from the wind, although it's not much, but it's very well integrated in the built environment. And also you see here the roof and the photovoltaic, high concentrating photovoltaic production. This is the Fresco. This is a desiccant and evaporative cooling air conditioning system designed for ventilation, dehumidification, and cooling in small scale applications. And this was prototyped and tested by Enea, which is an Italian Ministry of Economic Development project. The energy management, we had also Wi-Fi, smart controls of the environment, also ways to show the environmental conditions and interconnect the systems with the users and to provide information with the users. And all these are connected through to the WebGIS platform. You see here in the settlement level, we have occupancy, temperature, electric loads, air velocity, magnet read, contact doors, domestic heat water, and all these are connected with the WebGIS platform using a REST API application. So we took various vendors and various systems and energy technologies and sensors, and we managed to interconnect them all to the WebGIS platform. So we have a global monitoring platform to collect all the data and compare the data between the various case studies also. The same happened with the energy technologies, with the REST API platform. This is the interconnectivity of the various energy production technologies, and this is also through the inverter with one connection. We have interconnectivity with the WebGIS platform. What we measured and what we calculated. First of all, we wanted to have advanced technology, advanced algorithms to predict the energy production and the energy consumption at least 24 hours ahead in order to be able to perform some adjustment of the loads. So, for example, for the energy production technologies, we measured the energy produced, the rejected energy that is not used by the settlement, the energy consumption of the settlement of the various buildings, the global solar radiation, the wind speed, the same also for the other solar blocks for the photovoltaic insulation, for the photovoltaic panel, and all these are inserted in the database and calculated and presented through a web browser to the users. We used GIS, although it was a big tool, because we wanted to have to be expandable to be able to include more settlements in the future, and also to be able to use this platform for other projects and other applications. I will talk now about one case study in Italy. These are the two, the area. These were constructed in the framework of the project. It wasn't existing, and we did some retrofitting. No, these were constructed, which means that we had to take all the permits, all the plans. It was a very, very heavy work. You see here the total floor area of 2 residents, the net floor area of the 2 residents, the orientation, 2 stories for the first one, 1 story for the second one, 3 bedrooms, and then you see the characteristics of the walls, of the roofs, U values, the windows, UG, and the glazing that we use, and manual blinds for the shading. These are after constructed. I have pictures also during the construction. You can see also in the website more information about that. So the technologies were a dedicated greenery for local overheating mitigation, because we are in Italy and we thought that greenery will help to reduce the outdoor temperature in order to reduce also the energy consumption of the buildings by minimizing the difference between indoor and outdoor conditions, especially during summer. We had PV panels, as explained also in the beginning, XPS insulation, energy storage systems, load controls, and home energy management for building energy management. Not all technologies used in all projects, because we had a lot of problems with the permits, with the legislation. And of course, if you do a construction, a real construction, you have to follow the local legislation and the standards and the rules. Now you see here some results. This is the energy signature, as mentioned, as energy signature of the buildings. Here we have the outdoor dry bulb temperature from 0 to 40. Sometimes it's below 0 at a specific area during winter. And these points are the simulated consumption of heating, ventilation, air conditioning of the buildings, and also the measured. We simulated more, so and the measures were less. So you see here, for example, the inclination of the graph shows that for higher temperatures, we have less heating, ventilation, air conditioning consumption of the measured compared to the simulated. So although we designed with the simulation, at the end, the measured conditions were even better than the ones we expected. And I will show you that also in a graph and in a table. So here is an overall graph of what happened to this settlement. You have here in gray all the settlement consumption. You understand that during winter we have some more consumption. The PV settlement or the energy production of the settlement, which is of course increased during summer, decreased during winter. That's why also we have these differences in self-consumption also. The self-consumption is the graph here, and you see some points which is 62%, 62%, 51%, 62%. Also, the grid import, the energy from the grid is increased here, because here, of course, we see that the energy consumption of the settlements is higher than the one anticipated, or the one that we can cover by the photovoltaics. And based on this graph, you see we have also the results of the yearly based results. So for the two residences, as designed, we had 50 kilowatt hours per square meter per year regulated energy. As built, 47.4 kilowatt hours per square meter. We are still collecting data on that, but you see here also on the real, for the second residence, we got for the first year less than the designed ones. So the consumption was even less. We are below the 0+ target, less than 50, not less than 70. We produced more energy than expected. And also we have some regulations here for the weather. And at the end, we have a positive energy instead of, so for the overall settlement, especially in Italy, we have a positive outcome of energy production versus the energy consumption on a yearly basis. Of course, you understand that we have to import energy from the grid, because at some periods the energy produced is not cannot cover the energy consumed, and to design for storage increases, of course, the investment cost. So I close for that, for the monitoring part and the results. Sometimes it's very important to measure, because we realize that things might much more better than when we expected. And based on that, I will move to the second part, which is the smart grids, and what we've done in the framework of a Marie Curie project that was running in the last 4 years with a number of partners from all around Europe and also from Singapore. I don't know if we have to say a lot of things. I know that a lot of people around here know what is a smart grid. Just for those that are not familiar, a smart grid is an evolved electricity grid that is not one-way communication, is two-way communication, allows two-way communication between the user and the system back to the user. Also, it operates in a reliable and economic manner. It exploits information and computer technologies and facilitates integration of various technologies. So you see here our plan. This is what is involved in a smart grid. It's ZEB and smart residential buildings, is geothermal plants, control rooms, microgrids, smart meters, zero energy buildings and smart residential buildings. Sometimes it includes hydroelectric power. This is the grid connectivity, big buildings, solar thermal power, energy storage. All these are parts of a smart grid or of the energy system. And we have here the academic partners, the academic people and the industrial people. I'm not going to say a lot of information about that. It's people from all around Europe, and here also industrial partners from all around Europe. And you see which one of them are involved in the various parts. So we had a strong collaboration between industry and academia to evolve this smart grid concept and to understand how things are incorporated in this smart grid concept. To be more specific, we had 3 phases. The phase 1, we focused on smart and zero energy buildings performance and how a smart building provides data to a smart community, to a smart grid, and allows the two-way communication. Then we move to a more bigger cycle to components, to a smart grid penetration to a community and a city level. And then we have in phase 3, integration of components to the development of smart applications and optimization of smart grid performance. We worked in around 3 case study areas. The first one is called the MyLeaf community, which is in Italy, in Marche region, that includes zero energy buildings and zero energy offices. Also, they have in this MyLeaf community a small hydropower plant, photovoltaics, storage, a lot of technologies. You can see here also which technologies are included, and you can ask me later if you want some clarifications. Then we have a big installation of energy production technologies in Italy, in Palermo, where you see here the installation of linear Fresnel and other technologies that were exploited in this work. And we have some installations that were performed at the Technical University of Crete that I will discuss, of course, in my next slides more specifically. So we had 3 main focus areas. People were visiting these areas, and we exchanged the knowledge and ideas. And also we saw a lot of things from the smart metering aspect using the expertise of our industrial partners. So about TUC. TUC expanded the infrastructure of smart metering, I think in 2017. There was 1 point of delivery here in the beginning, so the connectivity with the grid was 1 point for overall campus. So we knew the consumption of the overall campus by 1 point. We couldn't know the breakdown of consumption in the various areas. So you see here how the smart metering was distributed. We have here the production engineering management offices and laboratories, the sports facilities, the dormitories, the sciences and electronic and computer engineering, our part, and also the mineral resources engineering department. There was 18 smart sensors installed that gave us a lot of input and a lot of ideas how to work. Also, we managed to have a very good detailed infrastructure in the 2 buildings of the environmental engineering department with a connection of temperature, relative humidity, CO2, lighting, smart meters also in labs to understand more details here, because it's our lab and we wanted to have more. I have some time, okay? And then we used these smart meters and the topology and to perform some predictions of artificial neural network predictions of the next day's consumption of the campus, and to see if a demand response, if it's possible with demand response, to minimize the energy cost of some buildings or some facilities. So here is an outline of the cost of the installation of the meters. And here you see what we did. We took the data, the historical data of the smart meters. We performed, we tested various artificial neural network algorithms, which is algorithms that operate like the human brain and be able to give accurate predictions based on historical data. You see here, for example, the data we used for training, which gives a very good fit, more than 90% R, and also very low, the distribution around the line is not very big. Also here we have the validation and the testing, and for overall the relation between the measured and the predicted data was really good for all smart meters. I just saw 3 here, and not all, although for all was really good, because we had very good historical data that we used, and also a lot of years, because we started this work around 2019, so we had at least 2 years data. Then after that, we performed a demand response algorithm. Demand response is a way to respond to the demand by minimizing various energy consumption items and respond to the cost of the energy. I won't go into the details. We start, we process the data, we do the prediction, then we optimize and we evaluate the various demand response solutions, and we select this that gives us a reduced cost of the overall system. So if you see, what we did actually is we took the district cost baseline, which was that in 1 day, for example, for the summer. And what we did is we took this curve and we did a bit of load shifting. We shifted the energy consumption to hours before and after the peak. This reduced the energy cost, and we did not jeopardize the thermal comfort and the necessity of the energy requirements of the building. So the total area below the total energy consumption for the 2 cases is the same, but what is changed is the cost also for this and for those 2 solutions. And only by shifting the load to hours outside the peak hours, and by leaving also the energy load the same, we had at least 14 to 16 reduction of the energy cost. This is very important to select, of course, what type of items will move to these hours, because you cannot do it for the labs or for whatever. It's something that should be decided, prioritized. Finish with that, with the smart grids, that well, I would like to talk about these climate change challenges. That is very, very important. And you see here a graph that we had in January 2019. On the one hand of the earth, we had Canada, the same day. In Canada, we had minus 27 degrees and 47 in Australia. So it's amazing the temperature difference and the air circulation around the earth the specific days. One of the main aspects of this is that the energy consumption in cities will increase because although we try to mitigate climate change, we need energy for the cooling. And this is also is a problem not only for our areas, but now it's becoming a problem for the northern European areas, or for the northern countries, higher latitudes, because they are not used to this cooling requirement. They don't have installations, they don't have air conditioning, they just have heating systems, and they suffer. So a lot of people is working on how to integrate renewables in cities. Two works that we've been looking is, one is how to include photovoltaic pavements, and this is some work that we've done with some colleagues from the University of Athens, and how to see if we can use photovoltaic panels and how this with the dirt and all the problems we can integrate renewables. And the other thing is this nice tree that has these small wind turbines as leaves, and takes energy from these small wind turbines and provides energy to the neighborhood without interfering with the environment, at least in my perspective, because also very subjective. Another thing that we want to look out is urban allotments and urban gardens, way to increase the greenery in the cities, because the problem now is very, very serious. And if we include greenery and gardens, this is a part of my garden, actually in my house, and we model that using Envimet, and realized that if we change the surface of all the area with greenery, then the temperature around reduces 1 to 2 degrees, and then the surface temperature decreases 5 to 10 degrees from the scenario compared to the existing scenario. Also, urban forest restoration is very important for the CO2 sequestration, to stabilization of the ecosystems, to urban heat island mitigation, and of course to reduce the energy demand for cooling. And then we move to a very important aspect that is called integration of nature-based solutions. I worked on that in the last 3 years. In collaboration with my colleague, Professor Nikos Nikolaidis, we started with a project called Think Nature, which is the integration of technologies and of projects and how to disseminate this concept. And what is nature-based solutions? I use the European Commission definition, is living solutions inspired and supported by nature that simultaneously provide environmental, social, and economic benefits and help to build resilience, bring more nature and natural features and processes into cities, landscapes, seascapes through totally locally adapted and efficient systemic interventions. So we target, in my perspective, because there are also others, for example, ecosystem restoration, which I'm not very much familiar. It's sustainable urbanization of cities, and you see here a picture of Yanzhou Park in Jinhua City, where you see the park while it's not flooding, and during the floods you see that people can move in and around the city using these bridges, and also the water is not flooding down because it's absorbed by the surface. Is someone want to say something? I heard something.
All the attendees are muted, Denia, so probably it comes.
Okay, sorry. Now, in urban scales, nature-based solutions start from the building scale, local scale, and regional scale. It's green roofs, gardens. Local scale is urban parks, urban pocket parks, green urban living rooms, ditches, infiltration strips, and meadows. In regional scale, we have urban forest restoration, peri-urban parks, noise barriers, ventilation grids, corridors, porous paving, etc. Now, how we make that into practice? So after that, we decided that we have to move on to implement something. And we started the project last September. In this project, I am the coordinator. We are 25 partners, a lot of people from all around Europe. Also, the municipality of Chania is participating with a case study, and I will talk about that. Our vision is to implement real and visionary ideas into using these nature-based solutions, but also to exploit digital infrastructure and to promote social and cultural innovation. What we want to achieve is to shape the future cities by developing nature-based solutions to tackle the city's challenges, to create these innovative solutions in a framework of digital, social, and cultural aspects in 8 cities, not just looking for the technology, but also to the people and to the culture. Support co-design and co-creation process. So include the people in the decision process. This is very difficult now, but we're managing with this COVID situation. Develop a monitoring framework, again, based on our experience in other projects. So expand the monitoring. Assess the sustainability and impact of interventions by developing and advancing key performance indicators for health and well-being, and also in sustainability. And support innovation for governance, business, and finance, and new opportunities for Europe and network of stakeholders. So here you see our concept. We have these 8 pilots. I won't discuss about a lot pilots, but just I'm focused on Chania. These are focusing in different aspects: climate change mitigation, urban ecosystem regeneration, sustainable governance aspects, but all on environmental stress reduction, tackling social tension, access to culture, improving health and well-being. They provide data to the cities platform, which is also fed by GEOS, Copernicus, citizens observatories, and we target to a lovely future cities, happy cities that stakeholders, industrial partners, researchers, and NBS projects are incorporated in these 4 dimensions of nature, digital, cultural, and social. The pilots, we have a lot from the 4 north. I'm very anxious to go there to see the aurora, to the big down south to Chania, also Ireland, Leuven, Castelfranco in Italy, Novo Mesto, and Malta. So I said about our impact. I will say a few things about Leskelefia, or I can, how much time do I have, Kostas?
Denia, officially you have 10 more minutes, but I mean, you can use your time as much as you can. I think that
okay, I have 10 minutes, then I will say a few things about up north, because it's very interesting to see what others are doing, I think. So the objectives, all these pilots, they have a big project in the city, and our project is anchored in this big project of the city. So we don't do all the work, but we do the innovations of the work. What they want is to develop a new residential area by using an old landfill area. So they want to create urban resilience by natural infrastructure, wetland buffer that reduces pollutants and reduce stormwater floods, to increase the biodiversity of this old landfill area, to create an inviting meeting point in the nature for residents, and initialize this classroom in the nature for preschool and school citizens, and also to level up the awareness of the problems of climate change, biodiversity problems, and the importance of creating wetlands. What we are doing in this pilot is to support infrastructure to create this urban resilience, I mean the digital infrastructure, to create these wetland beds to increase biodiversity, installation of smart lighting, engaging citizens, and support this classroom in the nature by developing various events on these nature areas. Another very interesting pilot is in Bergen. Bergen is a big area in Norway, very, very beautiful and very touristic. And they want to create what they call it a city beach, an area in the city that people can go in there and be able to lay down during summer and have to be pleasant, because they're in these areas also during summer they want to stay out, to create the green mobility, to promote health of the park users, to preserve biodiversity in Greek park zones, and also, of course, to measure health and environmental aspects. And so this, we will create a digitalized urban water park in the city beach. We will have augmented reality applications for inspiring more physical activities in the areas of exploration. We will have optimized biodiversity in the park by including other species that are local species, and Bergen City Beach health effects assessments. Another important, very interesting also is Castelfranco Veneto, that there is a garden there for elderly people and people with Alzheimer. And the city of Castelfranco will restore this garden. And we will go ahead and also, not us, but partners from Italy will check how this environment affects people with Alzheimer and people, elderly people, their perspective, how they feel, if they relaxed, monitoring of psychological and physiological well-being. They monitor the microclimatic conditions, the implementation of virtual and ICT technologies, and also they get children in the park to be very close to the elderly people. It's a very smart pilot, that. And of course, I will finish with Chania. Chania is an area that is a lot of things are happening and it's been restructured and refurbished, redesigned, and we have a lot of areas with sidewalks and bike paths, although there are some reactions on that. The aim of the pilot in cities is to increase the sense of respect of public spaces, to develop green areas for children and people, to improve the economic opportunities through digital green strategies, and to increase urban interaction in these areas. You know that in Greece, if you do something that is stable there, you have to get a lot of permissions. So we decided not to go to that, and we're going to go to a mobile urban living room. So what we're going to do is going to be mobile, moving around, and we won't need a lot of permissions for installation of urban living room with the local services. So we are going to design mobile urban living rooms and sensors on bikes and bike stations that will will exploit these bike sensors to measure air quality or to measure various parameters that influence health of the people or also influence the comfort of the people. How this idea came up with Chania. In the previous project, we had a summer school. I will give you some idea because this is very interesting. This is the summer school we did in September 2019. We had people from 40 countries, 20 countries, 40 people. We had a lot of work and a lot of fun, as you see. That's what usually happens in summer schools. And we gave them, to these people, the Chania city as a case study, a study example. We explained them. I don't want to go into details. The orientation, we had a lot of walks around the city. We explained the problems. Here you see how they call them, the fortifications. You see the Venetian fortifications and the Byzantine fortifications, and how the old town is separated from the modern city. The problems of the small areas in the old city, and you cannot, of course, change the facades. We had some measurements in the past showing that we have an urban heat island phenomenon in Chania, because in the center, the temperature is at least sometimes reaches 6 degrees difference or 7 degrees difference with the peri-urban. And you can understand that if you take your car from the center of the city and you go to the university here that we are in Convidiana, you understand the temperature difference very, very easily. You feel it. Then we have also gave them some information from a climate change disaster from extreme weather conditions 2019, early February. You see here very nice images from this event. We had 596 millimeters of rain in 2 days. Routes were destroyed. You see here images from the old city, harbor, from the beaches, from various areas, and also floods and all these problems. And we asked these people to give us some ideas, because they are French minds, they don't live here, some ideas of what can happen. And one solution was the Fibonacci vision. They gave us this very nice picture, which is a Fibonacci sphere. Starts with blue solutions from the outside and green solutions inside. They suggested to have some reef balls and living surf lines here to mitigate the floods and the energy that comes into the harbor. And of course, increase greenery in very smart way that does not affect the historical concept of the city. You see here some ideas from other cities, also some pavements and some ideas. Of course, this exists in Chania, and this is also a noise barrier, and night noise barrier and bench. Other was the fixed team that they wanted to put. Here you see from Montreal some ideas that came up, how to incorporate greenery in areas, two-way streets, and add greenery between the stairs, and have some greenery around. Also to have roads that have areas that have soil retention paths, instead of having only the asphalt that does not allow, that does not absorb the water. They actually focused a lot on the clouds. And then we model a bit the solution using ENVIMET. We have here some, the temperature, average temperature, wind speed we use for Chania. And we took some spot lines around the city, and we tried to see what is going to happen if we incorporate small green aspects, and also some new pavements that have increased reflectivity that does not absorb the heat. It says these areas are not, of course, something should be done, but it's areas that we selected. Here you see there is some greenery, but during this period, you see that there's no shade at all. Or you see here that if you have shade, the area is much more pleasant, and you can walk, you can stay, and you can also communicate with other citizens and people in the city. So we have, with all these solutions, we realized that you can have the surface temperature reduction is 12 to 17 degrees. Of course, it's not something that we suggest to be done, but is ways that we started thinking about solutions. And what we are going to implement is urban living rooms that we decided together with the municipality of Chania. And also we got this funding from the project Varsitis that I mentioned earlier. So with that, I conclude. I would like to thank you for this opportunity, and I'm open for your questions and comments. Thank you.
Thank you very much, Denia. Please stop sharing the screen with us. It was a very nice presentation and very inspired, inspirational. So any questions before I will start with mine? So let me try to trigger them or answer, make my questions, Denia. First of all, I would like to ask you a general question regarding these smart cities. What about since everything is linked with the IoT, I mean, the cost of building such a smart, let's say, building, the maintenance and the installing, the effort that you should make in order me as a citizen to train me how to use all these facilities, and the cyber security, how do you address all this stuff?
Very interesting. This is very tricky. You need consent of the users. We took consent of all the users that we took the data. So first of all, you have consent forms. And about the cost, first of all, people are much more familiar with these technologies if you give them the front end that it's easy to use and download an app. So if you have a very user-friendly app and they don't see what they want, and you ask them, what do you want to see? so you have them integrated in the solution, then you have much more chances for them to understand, to apply, and to implement something. Otherwise, if you do something, you install your system, your smart system, and you take the user and you say, tell them, oh, go ahead and use it, it's no way that's gonna operate, and we know that from experience. First of all, you have to take the users and the people from the very initial steps, and that's what we did in all the projects. In the Zero Plus, and also now in Varsitis, we're starting with stakeholder engagement. We don't start, we have some ideas in our minds that what we're going to implement, but people were going to say that we want this or this and this. Not only the municipality, we have not to exclude anybody, especially the minorities. This is a very critical point now, the European Commission. You need to make sure that you don't exclude the minorities. So,
Denia, and so in this kind of effort that it's I mean, I totally agree with you that it's a key issue in order to introduce a new technology, any new technology to the masses. Do you include the social scientists?
Of course. Okay. Of course. Otherwise, social, legal, neural scientists of the brain. Mm-hmm. It's not a team that is not a team made by engineers.
Yeah, totally. And I have a technical question. I like very much the what did you present regarding the solar cell pavements? And the question that I have here is the following. I mean, how do you solve the problem with the dust? Because dust is a killer factor regarding the performance. And another one is like, since these solar cells are on fixed angle compared to the sun, how do you manage to optimize them regarding the maximum flow? So, so about the dust,
put them there, and you have some consumption that you didn't expect it to have. In these cases, if you want to integrate renewables, in my perspective, maybe some other colleagues have different opinion. Is if you want to integrate renewables in the built environment, sometimes you don't operate in optimal way.
Yes.
Most of the times you don't operate in optimal way. If you saw this wind rail that I saw this is not optimal. It's a big construction, and sometimes it's not cost optimal. And for that reason, we optimize that with different orientations, with two permissions. But you don't optimize as you optimize with the photovoltaic farm that is in the rural area.
So I suspect that the cost-effective, how can I say, report that you have made or the research, this means that the installation, the cost of the installation, what do they produce is more than what are you losing? Am I right?
Yes.
It's cost-effective. I mean,
yes, it's a cost-effective, but it's a cost-effective compared with what other alternatives we have.
Yes. Okay. Yes. Yes. And can I ask a last one? Because I miss it.
You are the manager. I'm not.
I'm not the manager.
Yeah, you are
what about thermochromic windows? Did you mention them? Are you using them during the smart buildings?
Thermochromic windows.
Yes.
Yes, I try to work on thermochromic materials, not only thermochromic windows. Thermochromic materials.
Material. What do I mean?
Yes, yes. There is a very tricky point there, because there is a lot of research on that, because these thermochromic materials may reduce the heat penalty of areas during winter, because if you put a cool material, you have some reduction of the energy during summer, but you have some heat penalty during the winter sometimes. Mm-hmm. And this reduces the application of the system to a small latitude, to lower latitudes, not to higher latitudes. Mm-hmm. But I haven't seen something really persuasive. The test we had here in the lab with thermochromic materials is that they last for some cycles, and after that, the sun destroys the cycles because it's organic matters, mm-hmm. and the organic bonds are destroyed.
Okay, because of the temperature, right? Okay. Yeah. And the last one, since they don't speak, what about the impact of the 5G communication in all what are you doing? I suspect that all the How did you mention? How did
To
you
answer as a joke or to answer seriously?
seriously? Why?
Okay, because the 5G are also linked with the pandemia.
No, I'm not one of them that they believe this. I
Tanya,
also
this is
believe
recorded,
that
so
I
be
had the
careful.
vaccine.
It will be on the
I'm
website.
joking.
What about, have you taken any consideration in order to integrate them within your web GIS systems or whatever you are doing?
Not so far. You understand that for smart cities, there are specific protocols and communication technologies used on LoRaWAN, I think, try to remember one, LoRaWAN.
Mhm.
And we base our communications on the most suitable technologies for smart cities, and we see how this will evolve.
I was very much impressed with Barcelona, because Barcelona, I was in a meeting regarding Barcelona and some Israeli universities, and they showed very clearly like how the 5G has an impact to Barcelona now as a whole smart city, and I was very much impressed. That's why I asked. Okay, the floor for the audience. Any questions? A part of the thank you, incredible presentation, etc. Questions?
Please,
Okay.
nobody.
It was very clear, I suspect. That's why. And also they are very gentlemen.
Oh, very boring. I
No,
don't know.
it was not boring. It's something that I will say you, Denia, it's a priority also in our European university. One of the priorities are the smart cities. So probably we will call you and we will invite you in more actions. And it was a pleasure to collaborate always with ex-colleagues, but now very famous and very, no, let's not mention famous, very successful scientists around us. So thank you, all of you. I would like to
Thank you
wish
very much.
I would like to wish you Merry Christmas and Happy New Year with Sai Cafe.
Somebody is asking to share the presentation, Kostas.
I will upload the
Having problem. All these are
Yes.
our work that is published is already. So I can send you a link because a big one to see how you're gonna share it.
Okay, anyhow, I'm going to upload the video. That's why I'm recording everything to our YouTube channel. And only the people that they receive the link, you know, they can have an access and look at this again. So Merry Christmas, Happy New Year. We will be back with Sai Cafe on the 21st of January with another dynamic lady, Professor Hadzaki, from the medical point of view. And I hope to have you with us also in this lecture. So Happy New Year and Merry Christmas. Thank you, Denia, again.
Thank you very much, everybody. Thank you.
Thank you, Denia.
Χριστό, γεια σας.